Welcome to Luvitex Engineering, where we sketch out the things that keep the industrial world moving. Now, let's start.
Today, we're diving straight into a high-stakes, completely invisible battle that's happening right now inside our industrial infrastructure. Seriously, every single day, there is a hidden war being fought just to keep the engines of our modern world running. And the crazy part? It's happening right under our noses. Now, if you look at the basic definition, an air filter is just a device that filters out foreign particles in the air. Sounds pretty straightforward, right? But the reality of what these devices actually protect is absolutely staggering. We are not just talking about keeping the dust off your bookshelf here. We're talking about defending multi-million-dollar machinery from a constant, never-ending assault. To really understand why this matters so much, you have to think about this ratio. A massive gas turbine ingests 98% air and only 2% fuel. Let that sink in for a second. 98%. While fuel is obviously what provides the power, almost everything that turbine actually consumes is just air. So making sure that air is clean, it's absolutely crucial. It is the single most critical factor in power generation. So to wrap our heads around this massive problem, we're going to quickly walk through 5 things. We'll look at the invisible air invaders, how we go about measuring the microscopic, the filtration arsenal we use to fight back, the ever-present threat of clogging, and finally, the total cost of ownership. All right, let's jump right into part 1, the invisible air invaders and the microscopic threats they pose. So there are 5 major issues that airborne particles cause to a turbine. Think of it like a really bad respiratory disease, but for industrial lungs. First up, you've got erosion, where larger particles basically sandblast the compressor blades. Ouch. Then there's the plugging of cooling passages, which can trigger a total thermal failure. Next is fouling, which is when tiny particles stick to the blades and just ruin the aerodynamics. Fourth is corrosion, specifically hot corrosion, which happens when salt in the air reacts with leftover sulfur in the fuel. And finally, foreign object damage, or FOD, where larger debris gets sucked in and causes absolutely catastrophic damage.
It really is a classic David and Goliath scenario. You have these microscopic particles. We're talking about things like a 0.1 micrometer virus or a tiny single grain of sea salt, and they literally threaten machinery massive enough to power a city of 500,000 people. The invisible is constantly threatening the massive.
Moving right along to part 2, measuring the microscopic and how we actually set our filter standards. Let's look at the absolute heavy hitters of filtration. You've probably heard of HEPA filters, and they really are incredible, removing at least 99.97% of particles right down to 0.3 microns. But then you have ULPA filters, and they take it to a whole new level. They trap 99.999% of particles at 120 nanometers. To put that into everyday terms, a single human hair is about 70,000 nanometers thick. So these ULPA filters are catching particles almost 600 times smaller than the width of a hair. It's mind-blowing. Now, historically, different industries used totally different rating systems, which, as you can imagine, created a massive amount of confusion. But thankfully, we can finally bridge that gap. By directly comparing the American ASHRAE MERV ratings to international ISO 16890 standards, engineers all over the world can finally speak the exact same language when they're designing these defenses. But when we're talking about turbomachinery specifically, there's a particular standard, ISO 29461-1, that eliminates the confusion entirely. It does this by measuring mechanical or discharged efficiency. And this is a huge deal because it avoids the exaggerated effects of an electrostatic charge. See, a static charge can make a filter look incredibly efficient in a controlled lab test, but once that charge wears off in the real world, the efficiency absolutely plummets, which would leave your turbine completely exposed. All right, let's get into part 3, the filtration arsenal, and take a look at our frontline defenses. When you look at coalescing filters, which are specifically used for compressed air, the mechanics are just brilliant. Step 1 alone removes more than 95% of water droplets, oil, and large particles before the air even has a chance to hit the fiber filter. It basically forces the water to condense into larger droplets that just fall away. Then, in step 2, the filter generates literally thousands of tiny vortices to trap the super fine particulate that managed to sneak past that first layer. As you can see, there's definitely no one-size-fits-all in this arsenal. Choosing the right filter is all about matching the specific weapon to your specific environmental enemy. Panel and bag filters, those are your go-to for HVAC and commercial setups because they make great pre-filters and they're easy to swap out. Sintered bronze filters are incredibly durable and can withstand high heat or harsh chemicals.
And then, of course, your HEPA and ULPA filters are strictly reserved for when you need complete sterility, like in a hospital operating room or a microelectronics clean room.
That brings us to part 4, the threat of clogging, the primary antagonist in our story. Because here's the thing, a filter can only hold so much. Whether it's from a crazy high dust load, oil contamination, or moisture that mixes with dirt to form this thick sludge, eventually it clogs up and restricts the airflow. And when that happens, you get a massive pressure drop. That means your HVAC system or your industrial compressor suddenly has to work much, much harder just to push the same amount of air through the system. Now, this actually brings up a really fascinating question about maintenance, especially when we talk about infectious aerosols like the SARS-CoV-2 virus. When we're facing a serious airborne threat, I think our gut reaction is to assume, hey, we need to be swapping out these filters constantly, right?
Well, surprisingly, ASHRAE points out that the answer is actually no. Extending the time between filter changes is a legitimate strategy here. If you upgrade to a higher-rated filter, like a MERV 13, it might cause a little initial resistance, but it can actually hold more dust without a huge spike in pressure, meaning you can safely leave it in place longer. The tiny risk from not changing a filter exactly on schedule is practically zero compared to the massive protection you get from having a properly seated, high-efficiency filter running constantly.
And finally, let's wrap up with part 5, total cost of ownership, and what this all means for the financial bottom line. So the most crucial takeaway here is realizing that the initial sticker price you pay for an air filter, it's highly deceptive. If you're only looking at the purchase price, you are entirely missing the bigger financial picture. Believe it or not, energy consumption is actually the single most significant contributor to your total cost. All that extra energy used to overcome the pressure drop of pushing air through a clogged filter adds up fast. So a cheap filter that clogs quickly and creates a high pressure drop is going to cost you vastly more in electricity bills over time than a high-quality filter that keeps the air flowing efficiently. Let's look at a real-world example to put this scale into perspective. By tailoring your filtration to reduce those pressure drops and stop compressor fouling, a massive 700-megawatt facility can generate an extra $280,000 in output revenue. Plus, they save $96,000 in fuel and knock $34,000 off their carbon taxes every single year. That is a completely game-changing financial impact, all from simply upgrading an air filter. Ultimately, it all comes down to this. Investing in high-quality, energy-efficient filters leads to huge savings and better air quality in the long run. Viewing filtration as an investment, rather than just some disposable maintenance expense, is exactly what protects both multi-million-dollar machinery and human health. You aren't just buying a filter, you're buying efficiency, longevity, and safety. Which brings us to our final thought. If a microscopic particle can slowly take down a 700-megawatt turbine, what on earth is slipping through the invisible defenses of your facility right now? It's definitely a question worth asking the next time you walk past an air vent or hear a massive industrial compressor fire up.
Thanks for watching. For more industrial insights, check out our other videos. Don't forget to like, share, and subscribe to Luvitex Engineering.